Here we go. 4-1. I just did. Thank you. And now I'm hacking on the recording. So sorry. 4-1 is using graphs to relate to quantities. So we're going to be doing several things with graphing in this chapter. So before we start graphing like points on a graph to make a line, I just want you to understand how a graph works. When you're using a graph, you need variables. You need the things that we are talking about. So if you're comparing two different quantities like time and volume, those would be the variables that you label your graph with, right? I will tell you right now that usually if there is time involved, it will be your x-axis, okay? Typically, we make the time our x-axis. So if you're like, shoot, I don't know if this goes on the bottom or if it goes vertically. If it's time, it's probably on the bottom, okay? So I just want to show you this first one, kind of talk through it, and then we'll see how you do with those next two. This first one says, the graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Describe how the variables are related at various points on the graph. So you look here, your variables are the labels that we give it, okay? So your variables are volume and time. Okay, those are the things that can change, right? The volume of the balloon can change. The time that it's happening in is changing constantly. So take a look at what this graph looks like. It goes from 0 up, straight across, up, straight across, up, straight across, up, and then straight down.
Did the balloon pop?
I told you the balloon popped. Where did the balloon pop?
At the very top, you know it down.
Right, when it went straight down. The volume was pretty high, right? And it went from very high to 0 in an instant, right? There was not much time that passed for that to happen. So this is where the balloon popped. So what do you think is happening on these slants?
That's them blowing in air.
That's blowing in air. Over time, the volume's increasing, so they are blowing in air, okay? So they are blowing it up here, here, and here, right? Those up slants. What do these flat pieces represent?
Taking a breath.
Taking a breath, right? The volume's not changing, okay? So the volume's staying put. So it's like you blow up a balloon, and then you pinch it, right? Take a breath in. The volume of your balloon is not changing there. So those would be take a breath. Who had a hand up? Was that you, Shane? Yeah. So blow it up, take a breath. Blow it up, take a breath. Blow it up, take a breath. Blow it up a little bit. Sorry, there was one more little blow it up here. And then it pops, okay? So that's what I'm looking for here is for you to tell me what are the variables we're working with, and then just describe to me what's happening in those situations, okay? So letter B. What are the variables in this first one? Bless you.
Thank you.
What are your variables? Khalees.
Time and length.
Yes, the length is your y variable, if you will. The time is your x variable. And what are we talking about?
Board length.
Board length, okay? The length of a board. So if we're talking about the length of a board, okay, so maybe it's like a 2x4, a board. You have this 2x4. If we're talking about the length here, is the length changing on this first little horizontal?
No.
The length stays the same, time is passing, okay? What's happening here? The vertical. It got immediately shorter, right? The length went from, like if you had to give it a number, we're not gonna give these numbers, but if you had to think of it as numbers, let's do this. Maybe this is 2, 4, 6, and 8, right? It's 8 feet long. What's happening to make it now 6 feet long? Because here would be 6 feet, right? What had to happen to that board?
It gets cut.
It gets cut. If you cut it, now that board is suddenly this much shorter, right? So all of the greens, all of the horizontals, your length of your board isn't changing, right? But all of the verticals here, you're cutting the board. Okay, so the red is cut the board. You could say the green is nothing's changing, the board is just sitting there. Board doesn't change. Okay, so sometimes these are just a little tricky to try to wrap your brain around. Like, what is actually going on in this scenario? So you really need to look at your variables. You really need to look at the shape of the graph. What's happening to the graph? How do the x values relate to the y values? Okay, take a look at this one. This is your June cell phone cost. Okay, what are your variables?
Cost and
The minutes of a call and the cost would be your variables. Tell me what it means that your cost is a horizontal line until you get to here. What does that mean?
you didn't change the same amount.
Same amount of time.
You pay a set amount of money, whether it is 1 minute or 10 minutes or 20 minutes, right? You're paying a set amount of money. What happens after it reaches this number of minutes?
It goes a lot higher in cost.
You pay more per minute, right? The cost is increasing once you hit a certain number of minutes. So I would say this red portion here is just a set cost for your calls. Whereas when it starts to increase, now you're paying the cost per minute over your set cost. Okay, so your cost is increasing as you hit, those extra minutes. Does that make sense? Okay. Take a look at this next one. It says matching a table and a graph. A band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph best represents this information? So on day 1, their total downloads were 346. On day 2, their total downloads were over 1,000. Day 3, it's over 3,000. And day 4, it's over 10,000. Which one? B. You think B? How many days with their total downloads? What are your variables, first of all?
Total downloads in 3 days.
Yeah, so this is your X, right? Days is your X, downloads is your Y. Anybody else think it's B? Anyone else think it's something else? We're just uncertain? Or we're just not really trying to think through it right now? Why do you think B?
Well, it goes, it has like a bigger separation between the 3rd day and the 4th day than the others do.
Right. So if it was a straight line, right? If it was this one, it's going, like each day, it's jumping up by the same amount, right? That's a straight line. That's not what this is doing. This is like 700 more. This is 2,000 more. This is 7,000 more, right? We're jumping big each extra day that it's out there. So like this one, we're jumping less each day, right? That gap is shrinking. But on this one, the total number of downloads jumps bigger here, jumps even bigger right there, right? So that would be your letter B is what that one should be. Okay, so you're taking this information and just seeing how does it relate on the graph itself. Questions on that?
On the homework, like we're literally just like circling the graph that we.
if it says which graph represents this data, just circle.
And just think about
We
it
just
and then, you know.
Yeah, there's no like work to show.
Okay.
Is that what you're asking?
Yeah.
Yeah.
Multiple choice kind of thing?
Yes.
Okay.
Mm-hmm.
That's all we're doing for
No, that's one of the things,
Yeah.
but like the other stuff too. Okay, look at example 3 here. It says the table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph represents the data shown in the table? You good?
Yeah.
Okay, so we have at 0 uses, there were 5 ounces. Okay. At 1 use, there were 4.8. After 2 uses, there was 4.6. After 3 uses, there was 4.4. What do you notice here?
it goes down to
So each use, right, it's dropping by that same amount. That's linear. That's going to make a straight line when you graph it. So which one is it, Khalees?
why would it be C?
Why would it be? If this is the amount of sunscreen, right, and this is your number of uses. So at 0 uses, there's 5 ounces, okay? So 5, 4, 3, 2, 1, 0, right? So after, excuse me, 0 uses, there was 5 ounces. After 1 use, so you would go over 1, that's 4.8 ounces. After 2 uses, 4.6. After 3 uses, 4.4. The reason it's not this one is because this would say after 5 uses, there were 0, 1, 2, 3. After 3 uses, right, this is 0, 1, 2, 3, there would be 0 ounces of sunscreen left, right? So this one is up a little higher because we didn't get down to 0, we only got down to 4.4. Does that make sense? Questions on that? Okay, now we're gonna see if you can make the graph. So I'm gonna do this first one with you, and then I'm gonna have you try those next ones. What time are we? Third period, 11:15. We're good. Okay, so example 4, it says a model rocket rises quickly, and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. Sketch a graph that could represent the height of the rocket during its flight. So I'm gonna let you try that right now yourselves. Don't worry about the fact that it might not look like your neighbor's or it might not look like mine. I just want you to think through that. But I think it's super helpful to think about all the different pieces that are happening, okay? So try to draw that flight and see what you get. Anyone want to come up here and draw their version? Khalees, let's see it.
Oh, okay. I did it like that.
Okay. Anyone's look like that?
Try to start.
Okay. Anyone want to try a different one?
Yeah.
Thank you, Khalees. Yep, right on there. ones look like that. You want to try to draw a different one? You try?
Well,
Thank you, Joaquin.
Mine's mostly like 26.
like it's like that.
Anyone's look like that?
Mine's
Kind of like that. There are definitely things about all three of them that I feel like are good, right? I would say this is probably the one that looks the most like what mine looks like, and I'll tell you why. I would say it rises quickly. So I liked Joaquin's like quickness of his rise, right? I would do it rises quickly, slows to a stop. So you have that like peak moment as the fuel burns out, and then falls quickly. So falls again a little, kind of at that same arc. It rises as quickly as it falls, or falls as quickly as it rises. But then a parachute opens. So if the parachute opened right here, then the time it takes to fall is lengthened, right? So then I did this. I went a little more gradual down like that. Again, mine is not the only way you could do it. There were good things to all of them, and if you can justify why you did what you did, you could probably argue that something about yours works well. When you do something like this, though, I want you to label your parts, because that's how I know what you're representing something as. So I would say here is where it rises quickly. Up here is where it's going to stop, because then it's got to change direction. Here's where it's going to fall quickly. Okay, this is where the parachute opens. And then this is the gradual fall back to earth. Okay, like I said, not the only way you could have done it, but this is how I did mine. Okay? Questions on that? Oh, you guys. That's my husband. He just said, love you, with a kissy face. Marry someone like that, ladies. That's recorded. Sorry if you're watching this. Okay. Number 5. Are you good on this? Questions about that? Okay. Example 5. Suppose you start to swing yourself on a playground swing. You move back and forth and swing higher in the air. Then you slowly swing to a stop. Okay, so back and forth. What sketch of a graph could represent how your height from the ground might change over time? Label each section. And then this is kind of a second question. If you jumped from the swing instead of slowly swinging to a stop, how would that graph change? So forget that part for now. See if you can just come up with a graph. Now, on this last one, I gave you your variables, right? It was your height over time. For this one, I didn't give you the variables. Ooh, that's not great. We'll try that. But let's see if we can come up with the variables. What did I say is often the horizontal? Time. Okay, so we're going to put time there. Okay, what is the vertical one going to be right now? Could represent your height from the ground. So this is going to be height this way. Okay. We'll say our height is going to be in feet. And this time, do you think time would be in seconds, minutes, hours?
Seconds.
Probably seconds, right? You swing for a set number of seconds, probably. So our time in seconds, okay? I think this one is a little bit tricky, how to label it. Okay, I'm going to tell you what I did, but I'm going to give you a couple minutes just to think through it first. Not even a couple minutes, 30 seconds to just think about what would this look like. Oh, I feel like I even labeled mine goofy. Okay, here's what I did. Tell me if yours looks anything like this. So I'm starting with my feet on the ground, right? So that's that like 0, 0 on a graph, okay? I would say you swing forward and get up a little high, and then you're gonna swing back toward the ground, and then you're going, this is your backswing now, right? Because you're going here, and now you're getting further away, but you're swinging back, but you get a little bit higher, okay? So now we're gonna swing forward and get a little higher, and now we're gonna swing back and get a little higher, okay? This said, you move back and forth and swing higher in the air, then you slowly swing to a stop. So where was I? I went forward. Yep, and then this is backward. And then I'm still going backward here. Now I'm at the far back when I'm up here. And now I'm gonna go forward, get close to the ground, keep going forward. And now I'm here, right? This is the high here. Now I'm gonna go backward. Here's the ground, keep going backward. So now I'm up high, right? So if I'm gonna start slowing down now, I'm going forward, getting close to the ground, but now my arcs are gonna start to decrease. So now I'm back, now I'm forward, and now I'm back until I stop. So maybe I got kind of farther away. These would probably come down closer still. Sorry, I was getting too far away from the ground. Does that make sense? It's kind of tricky, right? Because you would think like forward, backward, but really the swing, the close to the ground, when you're close to the ground, you're still going backward. And then that like high point, now you start to go forward. So it's really like they're looking at each other on the arcs, backward, 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 backward. So forward, forward, backward, backward, forward, forward. And then on the way back, you stop at the ground, okay? So I would do something like that. What if I jumped off? Usually you jump when? When you're super high, right? So if you jumped, like say you jumped right here, okay? If we were going to jump at that, where was I there? Oh no, I was back there, huh? Backward. So I'm at the back. We wouldn't jump there. We would jump forward. We would be away from the ground here and jump. What's gonna happen?
We're gonna go straight.
You're gonna go pretty fast down to the ground, right? So this, if we jumped, it's gonna look something like that. Does that make sense? So the blue, I would say, is the graph that they first asked for. The red is what if we jumped. How would it differ? This is how it would differ if we jumped. Does that make sense? Okay. I think this one's a little easier. Example 6, when Malcolm jogs on the treadmill, he gradually increases his speed until he reaches a certain level. Then he jogs at that level for several minutes. Okay, gradually increases, jogs for several minutes. Then he slows to a stop and stretches. After this, he increases to a speed that's slightly lower than the one before, jogs at that speed for a short while, and then slows to a stop again. What is a possible sketch of that? Give it a go. I'm going to help you just lay out your variables real fast. What would you say is your x, your horizontal variable? Time. It's going to be time again, okay? This one might be minutes because you probably run for a little while. I won't even make you do that. Just tell me time. What is this one going to be? The vertical. Is what? Speed. This is going to be a speed. Okay, so try to draw that scenario, and then we'll be done. All right. What speed is Malcolm going to start from? 0, right? He's not running yet. So he's going to get on the treadmill and he's going to increase his speed. Okay. What happens when he's just met the speed that he's going to run at? It's steady, a steady speed for some amount of time. Doesn't say how much, right? Then he's going to decrease his speed. Okay. Now what?
He's gonna stretch.
He's stretching. So what's that going to look like on my graph? Horizontal, but at 0, right? His speed is 0 while he stretches. Now what?
Then he goes back up.
He goes back up, but what?
Not as high.
Not as high, right? It says he's running at a slower speed. So maybe he's just going here, but he keeps that speed for a little while before slowing to a stop again. Right? So if we were going to label that, we would say he's going to increase his speed. This is going to be a steady speed. This is decrease his speed. This is where he's stretching. This is a smaller increase. A steady speed. And then slow to a stop. Okay, and if you describe it different, like in different words than I do, but it represents the same thing, that's totally fine. If you want to play it safe, use the words they used to describe it, because that's what they told you should be happening, right? Any questions on that? Okay, so it's using variables. It's using these two different units. How do they relate to each other? What do we do with it?